Okay, dear students, how are you people? I hope you have revised your previous lectures. Now you have idea about branches, some conditional jumps and unconditional jumps, and how you are using flags for taking jumps. In this today's lecture, we are actually using these branches for our loop purposes. That can be for loop, while loop, but we are not today. We are going to do programming in assembly language, and similarly that you can use those instructions for time calculations or for delay purposes. How we will study today's lecture. So our today's lecture topic is actually loop, inside loop, and then delay. What is loop? In C, you have C that, for example, if I am taking example, for I is equal to 0, I less than 5, I plus do, let's say, some instructions, you perform these instructions 5 times and you check I. So I is actually your counter. How we can do it in assembly language? Here we need a counter, then we need a condition, then we need a. So what we are doing, for example, we are using LDI R16 0. This is our counter. I is actually our R16 because in processor we use our registers for any purposes, because our ALU can process mainly on our registers, R1 register or immediate value. So here I am used instruction load immediate value 0 into R16 register, and I will use this for my code. What code I want to run? These 3 instructions. Here in assembly I have these 3 instructions. Whatever are those instructions, I want to run these 3 instructions 5 times. So when LDI R16 is equal to 0, it will run this instruction, this. Here what I am going to do, I am going to use increment, or you can say add R16, add immediate R16 1. So what you are doing, you have added 1 in R16, add immediate value added in R16, and then what you are going to do after this, you are going to use your instruction branch. For example, branch equal, then I want to run these instructions. How many times? Let's say 5 times. So here I should need some label loop. You can start your label with any alphabet or with underscore, but you cannot start with special letters or with dash or something like this. So your label have some rules, and there should be colon after that label. Label is actually the address of this instruction. You want to go to this instruction, it will go in this instruction, and I have told you to check that this instruction how much big jump it can take by using this instruction. For hint, maybe 64k plus and minus 64k, or 32k plus minus 32k. You have to look at in your instruction summary. Okay, branch equal label loop. So what are you doing? First you initialize your counter, because first time this was less than 5, so these instructions will be run. Here you added R16 in 1, and what will happen? R16 will become 2. What is happened? Your result is equal to 0. Your result is not equal to 0. So if your result is not equal to 0, then this instruction can run? No, this instruction cannot be run. So I want to take jump 5 times. 1 I have run, so I want to take jump. So what should I do? Here I have to use branch not equal. Okay, so no branch not equal label 1, because this result add R16 1 is 1, and what I am doing, it will take and add 1, result is not equal to 0, it will take loop, then it will go here, it will run this instruction again, R16 will become 3, result is not equal to 0, it will become here, then result 3 not equal, result 4 not equal, result 5 not equal, it will. But what will happen later on? It becomes infinite loop. Why? Because this result, until by adding this value not become 255 plus 1, it will not be 0, and unless it is not 0, this instruction is true and it will take jumps. So what should I do? Have you got the idea? The idea is we initialize a counter and then we increment or decrement that counter. After decrementing or incrementing, we check either its value is equal to 0 or not equal to 0. So what is the problem in this instructions? We have here counter, this is the counter, we are incrementing that counter. We have here jump instruction, first we use equal, that was not working, now I used not equal, that is working, but no, it is not checking the condition 5. No, how we can check this? Can you tell me something? Okay, let's do another way. For example, if we are moving here 5 and instead of add, I use here sub immediate. I'm actually subtracting. First it was 5, 5 minus 1 4, 4 minus 1 3, no check. 5, this instructions will be run, okay, then its value will be 4, 4 is not equal to 0, so this is not equal is true, it will go here, run this instruction, then 3, then 2, then 1, then after 1 what will be happen? 1 minus 1 0. Now what will happen? No, result is 0, z flag is 1, z flag is not equal to 0, so then z flag is not equal to 0. What will happen? This instruction, no, it this time will not, and it will bypass and it will come to this code. So this code will be run 5 times, will be get executed 5 times. By how we use the counter in decrement fashion, and we use not equal instruction. Now if you want to run this instruction, let's say 50 times, what do you have to do? Only you have to change here 50. What is the purpose of loops? We want to run multiple times. There are two actually ways. Either you can repeat these instructions 50 times, write this instruction 50 times, write again 50 times, write these 3 instructions, then 3, 3, 3, 3, write these 3 instructions 50 times. That is one way of doing it. Let's say these instructions are X, Y, Z, X, Y, Z. So you want to write X, Y, Z 50 times, it will fulfill your objective. But the problem is when you are writing this instruction, these instructions will go to instructions memory. Instruction memory, what will happen? Instead of taking, let's say these instructions, these 3 instructions take 3 instruction memory units. So what is happening? 3 instruction addresses. When you are writing it 50 time it will take 150 instruction size memory. And if one instruction memory is 16 bit, so here 16 bit multiply by 150 memory of instruction memory will be get occupied by your this code. So now you got that this loop, actually when you are writing this loop, these instructions, if you are not using loop, this all instruction, multiple time instruction will be run here. This is the first problem. What is the problem? Problem in hardware. Your memory get not used properly. It is not using, you are not using it efficiently. Your memory will be exhausted. So we are using this loop method. The second benefit of this looping method is actually, which you have known already, that is, if you want to change this from 5 to 50, you do not need to repeat it from 5 to 50 time, only you have to change here value. Similarly, if you want to make it 150, you will only change here 150 and it will fulfill your objective. Similarly, here you can do. So we have two benefits. One, you already know, because this is good for programming, you do not need to repeat. But no, because of no hardware insights, you can understand that this is not benefit in programming, that you have, if you want to change your programming, this is a generic code. No, you can make it 5 times or 50 times up to your requirement, but you also are getting the benefit that your memory is using, you are using your memory properly. You are only using how many instructions will be now used? 1, 2, 3, 4, 5, 6, and let's say this take two instruction addresses. So 1, 2, 3, 4, 5, 6, 7. So 7 memory units or 7 memory addresses of your AVR get used here. Instead of, if you are using this 150 time, so it will use your 150 memory addresses. So you saved a huge memory. This was your good programming skill. This is the benefit of knowing hardware. This is the benefit of knowing your architecture of your processor, that how your memory has organized, how your processor has organized, and how you access your memory every time. Have you got the idea? Very good. Now we try to use this loop again, but let's say by using branch equal instruction. If any one of you have idea how we can use this? Any one of you want to tell? The problem statement is same, or our objective is not changed. We want to run these three instructions 150 times. 50 times. And now we want to use branch equal instruction. Branch equal instruction actually checks Z flag, and this will become true when our Z flag becomes 0. So we have to force our result in a fashion that it becomes 0 and this instruction get used, and otherwise so if instead of here I just write here, let's say R jump label loop, here I have label exit. For example, when you are using this instruction, it will come here, R jump label loop will come here, this will become infinite loop. This will become infinite loop. Now if here I used X, Y, Z, these are our instructions. Here if I used decrement or subtract immediate one, or I can use decrement R16, what will happen? It will decrement. And now if I use here branch equal loop exit, what will happen? First time R16 is 5, it will become 4. 4 is not equal to 0. This instruction will not be run. So it will run this and it will take unconditional jump, it will reach here. Again 4, no, it will be 3, 2, 1, 0. When 0, this will come out. It will not run this instruction. So what I can do, I can change it into 60. So it will run at 6, 5, 4, 3, 2, 1. So we can use it 5 again. I think I was wrong. 5, 4, 3, 2, 1, and on 0 it will be out. If again no, you want to use it 50 times, you only have to change it here 50. If 150 times, you have to change it 150. So what we used, I just simply use the method of branches. I force my ALU result in a fashion that my branch become true, or it should not become true when I required. How many time I want to become it true, or how many time I do not want to become it true, it depends upon my counter or equal. Here I want that my branch should not become equal. So for example 5 or 150 time, so I use in this fashion. But when in previous example I want that my branch become true every time unless it reaches to a particular value that was 55 or 150, and I was using in that fashion. So you can use other instructions that are dependent upon carry flag or your negative flag or your V flag, but you have to choose those instructions carefully and have to run those, or have to look consider those flags for when you are using it. Now this is a loop. We got two benefits. One, it is simple for programming. We do not need to write it 150 times this instruction, so we saved our programming time. Second, it is a generic, because if you want to change the value here 50 to 150, you are getting benefit. Third, your instruction memory only will take 1, 2, 3, 4, 5, 6, 7 instructions. Otherwise, if you repeat these instructions 150 times, you have 3 problems. One, it will take huge time to copy paste 150 times. Second, it will not be easy or generic to change. If you want to, let's say, increase from 50 to 150, you have to add 150 copies, or you need to remove 100 copies. That is the other problem. Third, your instruction memory will be taken inefficiently. So these are the benefits of loop. Now, how multiple times this loop can be run? I want to run this loop. How multiple times this loop? Maximum, how multiple times it can be run? I'm just going to take some easy example where we only focus on our loop instead of our instructions. Let's say you have LDIR 1650, you decrement R16, and here you say branch equal label. You moved 150 in here, you decremented R16, and you are taking this jump until it becomes 0. Unless this result is 0, you are taking this. How maximum time you can run this loop? Here you have, for example, instruction you want to run. How maximum time you can execute those instructions? depending upon this counter value, depending upon this R16 value, depending upon the architecture of your process, depending upon the data bus of your processor, depending upon the ALU size. ALU here in AVR can process 8-bit data. Register size is 8-bit. Your data bus is 8-bit. So maximum value that R16 can contain is 2 raised to power 8 minus 1. That become 255. So from 0 to 255 there are 256 instances, which by these times 256 times this loop can be run. Are you getting the point? If you want to run a loop, depending upon your this counter, it depends on the architecture of your process. So understanding architecture of your processor or understanding the ALU size or your data bus size is very much important. If you want to run more time than 256, what you can do? There are again two solutions. First, run 256 time, then repeat this and again run 256 time. Are you getting? And if you want to run, let's say 1000 time or 1024 time, what you will do? 256, repeat process, 256, repeat process, 256, 4 times copy paste these instructions and you will get 1024. So how many instructions will be used? 1, 2, 3, 1, and you are repeating this instruction 4 times. So 4 multiplied by 3, 12 times. And if you are also using here 3 instructions or 5 instructions, so 5 instructions will get replicated 4 times. So you can say 40 instructions. Again, you need more memory for this. No, again the question rises that if you want to run, let's say 2048 time, so you are making difficulties for your programmer. He have or she have to copy paste this code multiple times. Every time she need to calculate that how many time I replicate my code, and if she forget to replicate one time, it would be a huge error. Then secondly, it is not easy to change. It is not a generic code if you want to reduce or increase your number of repetition. Third, I have already told you there is a memory problem. So what we can do? This is the limitation of your architecture. No, this limitation can be solved by, in C you don't bother these things. In C you just simply write here 1024 or 2048 or whatever. You don't bother about this architecture. Your compiler do this all process for yourself. But here you have the issue. Here if you do not have instruction, there is nothing to increase it. So what we can do? What we can do, we can use multiple level loops. So here if I have let's say LDI R17 equal to 10, I want to run, let's say 250 100 times, or just I am taking example 1000 times. Easy example. Let's take easy example. I want to run these instructions 1000 times. These 3 or 4 5 instructions I want to run 1000 times. So this loop will run 100 times. 100 by 10 is 1000. So if I run this loop again by 10 times, my problem will get solved. So here I move the value R17 10. This all instruction will be run. Here I will use decrement R17. No, again I will use branch not equal label outer loop, and this is my label outer loop. So what will happen? Here I have loaded value 10 into R17. It will come here. This value is 100. This loop will be get 100 time executed. So these instructions, 3 instruction or what 5 instruction, they will be get repeated 100 times. After 100 times, this will become true and this will become not true, and it will come out of this. No, what will happen? Decrement R17. No, R17 was 10. No, it is 9. Here it is, when it is 9, it is not equal to 0 again, because no, this instruction will check the updated result of ALU. No, here result has been updated. I force my ALU to update its result, and it should not be equal to 0 at least for 10 times. So this will again take jump, come here. Now what will happen? R16 will be get reloaded with 100 value. When it is again 100, it will rerun 100 times. When it will run 100 times, so first 100, second time 100, here no value of 10, 9, no 8, again come here. So this instruction will be run by 100 multiplied by 10, 1000 times. So I want to actually execute these instructions 1000 times, and I fulfill my purpose. I only need to use 1, 2, 3 more instructions. So I only included 3 instructions, but my programming is generic and it is still a 8-bit architecture. No, I used actually 2 counters. So here when you are using 1024, this instruction is actually get translated to these assembly instructions. For example, if you are making the compiler, you may change this instruction into this programming instruction, and this can be a job of electrical engineer plus software engineer to change this C code into a particular assembly code or particular processor assembly code. You got? Now if I want to change, I want to run it 2000 times, what I have to do? Simply load it with 20. If I want to change, I want to run these instructions for 3000 times, I only have to write here 300. Okay, or for to run 200 times, you can do that. This should be 10, and this become 200, because I know that this loop can run up to maximum 255 value. So 200 is less than 255. So 100 multiplied by 200 is 2000. And now if I have here 20, 200 multiplied 200 is 400 times. So maximum loop can be run how many times? Maximum value that can this register hold is actually 255. 0 to 255, actually 256 times. And this can also run 256 times. So maximum it can run 256 multiplied by 256. So this is the maximum loop limit if you are using loop inside loop. So this is nested loop. In one nested loop, this is outer loop, this is nested loop, we can run 256 multiplied by 256. This is the limit of our loop. If you want to run it more time, then this 256 multiplied by 256, what we can do? We can use one other outer loop. So are you getting? In C you had only written this instruction. You were not bothering. That's why C is a high level programming. It is easy to use. If you do not have idea about your processor, you simply write C code, and most of time you have noticed that C language or C coding is almost same for any processor except your input or output units or some your special devices, analog to digital converter. If you are not using special modules, your C programming is same for all the processors most of the time. But why? Because then you have a compiler, then you have a other tools which converts that C language into particular assembly language of that particular processor in process. But here you do not have the hold of your processor. For example, here I could write 100 and here I can write 20 or some other changes. Here you have the hold of your processor. You are instructing every time, every second, every instruction that what should get executed. You want to execute this instruction first, then this instruction, or you want to execute this instruction first, then this instruction. Everything is up to you. You have to schedule those instructions. So you have the more hold, and you can notice that how many times your processor is performing which instruction and in which way. If you have idea of good assembly language and your hardware, definitely your C programming will get improved automatically, because you will have idea that what processor is doing. Okay ji, very good. Now we want to use these loops for delay calculation. Anyone can tell me that how to calculate delay, or what is actually delay, how we can use delay in processor, or where we needed delay, what is the purpose of delay? Gee, you people have 15 seconds to think about this. We have studied loop and loop inside loop. Now we are going to see that how we can use do loop for delay. What is first of all delay? Delay is that you want to do some work after some time. No delay, that is you want to do some task. For example, you want to turn on this room light and you want to turn off this room light, but after 5 seconds. How you can do? Here turn on, then give delay, then turn off. For example, 5 second delay.